for every natural number k when y is equal to x squared minus 4x plus k minus 2 vertexes on the first quadrant. This will going to be the second way to approach or solve for this question. At first, let's write our function down, which will going to be y is equal to x squared minus 4x. So y is equal to x squared minus 4x plus k minus 2. As we can see, this function, which will going to be our function that we're going to use to solve for this question, will going to be a standard form. So this will going to be a standard form. Before we approach this question, let's think about each variable's work or what each variable defines. So at first, our standard form, the original standard form will going to be y is equal to ax squared plus bx plus c. And we're reviewing exactly the same thing that we did in the last video to remind ourselves how to solve or approach this question. So first of all, our thing will going to be y. So y will going to be the output of our function. But if you think about that, output exists, which means the input should always exist. So our x value will going to be our input of our function. So this is one of the most important thing in our function. And now let's think about what is a. So for a will going to be a leading coefficient. A leading coefficient. Let's think about what is leading coefficient. Leading coefficient will going to be the coefficient of the highest degree power. And now let's think about what will going to be the c. So for c will going to be the y-intercept in the standard form. If you convert y-intercept into a coordinate, it will going to be 0, comma y. Which means when the x value, our input is equal to 0, our output, which will going to be y value, will exist. And this is what the y-intercept means. The reason is because we can also input our x value into our function. So at first, let's think about this specific term into our standard form easily. Y is equal to ax squared plus bx plus c. If we input 0 as our input of our function, this will turn like something like this. So this will going to be y is equal to a times 0 squared plus 0b, or we can write it as b0, we have plus c. A and hold this term that contain the x value will going to turn into 0, and we're gonna have c is equal to y, which we can see that c will going to be the case when x is equal to 0, and our y value will going to be c. So that's why we write c as our y-intercept in our standard forms. Now let's actually think about two types of our quadratic function, as we have reviewed in a lot of every videos. So there are two types of our quadratic functions, and we need to know that they're all defined by our leading coefficient, which we usually notated as a. So the first case of our quadratic function will going to be the case where the a value, our leading coefficient, is greater than 0. Which means when our leading coefficient is greater than 0, when it is positive, our graph of our quadratic function will go or opens upward. When the quadratic function opens upward, for example, it will look something like this. That keeps going toward upward and never intersect at specifically one point. But then it will going to contain a specific one point, which will going to be one of the most important thing that we need to know in our quadratic function, which we notated as the minimum point of our graph. Our minimum point can also refer to, say, lowest point of our quadratic function. And if you think about the lowest point on our graph, it will going to be defined when our leading coefficient is greater than 0. Our second case of our quadratic function will going to be the clearly opposite of our first case, which means when our leading coefficient is less than 0. When our leading coefficient is less than 0, the graph of our quadratic function will open or it goes downward. When the quadratic function goes downward, when the quadratic function's graph, it will look something like this, that never intersects at specific one point, but then you will going to contain one point, which is another most important thing in our quadratic function, which we're going to be our maximum point, and we call maximum point as our highest point on our graph, which we're going to define when our a value, our leading coefficient, is less than 0. And here we can kind of prove what a vertex is. So what our vertex is. So our vertex is same thing with adding the number of possibilities of the minimum point and the maximum point. This is what the vertex of our function will going to be. Before there was no difference with the last video, but now as we start to solve for this question, there will going to be the difference. So for our last video, all we did is we convert our function standard form into a vertex form. So last video we convert our standard form into a vertex form in order to solve for our vertex of our quadratic function. The reason is because vertex form is a form that is optimized when it comes to solving for our vertex of our function. But the problem for this vertex form was that it was inefficient, which means it took a lot of time in order to solve for the vertex, because as we convert our standard form into a vertex form, it contained a variable, which wasted our times. So now what we're going to do is we're going to use our new formula. This is not our new formula. We talked about this in a lot of last videos. So our formula of this will going to be the formula that finds the x-coordinate. So the x-coordinate of our vertex in our function. This will going to be our formula. And our formula will going to be, as we had talked a lot of videos, we know that the coordinate is defined by x comma y, where x is input and y is equal to output. The way that I'm doing right now will going to be way faster and then more efficient than the last video. This is the formula. Instead of x value, we input negative b over 2a and then comma y. There is a formula for the y value, but the reason why we don't have to memorize is because we know that x value will going to be the input of specific function, and y value is specific output of our function. If we just know the input of our function, we can simply input it to our original equation and solve for our output of our function. So that's why we don't have to know how to know the y value of our coordinate in our vertex. And so let's think about what this a and the b words. So a will going to be the leading coefficient. So a will going to be the leading coefficient of our quadratic function. It is same thing with that we talked about as a review, which defines the types of our graphs. Now let's think about what will going to be b. The b will just going to be the coefficient. So the b, which is located in the numerator of our formula, will going to be the coefficient of, so we can make a space of first power variable. So we're literally just going to be the coefficient of the first power variable. So let's actually input our specific values to solve for our equation. So our formula will going to be negative b over 2a, as we have talked about in a lot of videos. This is same thing with finding the x coordinate of our vertex. So our b value will going to be the coefficient of first power return. B value will going to be the coefficient of our first power return. Our first power return will going to be -4. Actually, the first power return will going to be x, which contains a first power, but our coefficient will going to be -4. So we're going to be negative and -4 over 2a. So 2 times a. But our a value will going to be the leading coefficient. In this case, our leading coefficient will going to be 1. So this will going to be our x, which will going to be the input of our function. So if you do it negative and a negative will turn to positive, we will have positive 4 over 2 times 1, which will going to be 2. We just simplify this a little bit, which will going to give us the output 2. But then we need to remember that 2 is the x coordinate. So it will going to be the x coordinate in our vertex, or of our vertex. But if you think about what is the x, it is the input of our function. Which means all you have to do is we need to input this back to solve for our vertex. So our original function was y is equal to x squared minus 4x plus k, and we have minus 2. All you have to do is we need to input value as 2 into our x value, which will going to be y is equal to 2 squared minus 4 times 2 plus k minus 2. All we did is we inputted value, our x value, as which will going to be input into 2. If we simplify, it will going to be 4 minus 8 plus k minus 2. Simplify our expression right over here. We will going to get k minus 6. So our y value, our output of our function of our vertex will going to be k minus 6. But the difference between our original coordinate and this one will going to be this coordinate contains a variable, which will going to be k in this case. So at first, but we can go back to our case because our if you just wanted to solve for the vertex of our function, the k value has a lot. And it can be either negative infinity to the positive infinity if there's no range. So when you think about the range, which we're going to be the limitation of the k value, which we're going to make our function. And in our function, in our equation, it says the vertex will going to be in the first quadrant. So it will going to be in the fourth quadrant. It will going to be in the first quadrant. If you think about the properties of our fourth quadrant, so there will going to be x-axis and our y-axis. So for our x-axis, for our fourth quadrant will going to be right over here that I'm pointing out. And this will going to be when the x value should always be equal to a positive value to make a fourth quadrant. So our x-axis, or the x value, should always be equal to positive in order to make this particular point. And our particular point will going to be the vertex of our function in this case. Now let's think about the y-axis. Our y-axis should be negative in order to make our vertex or some specific point in our first quadrant. So our y-axis should be negative value. This will going to be our properties of our first quadrant. And now we can think about k minus 6 as our y value. So k minus 6 is equal to y value. Our y-axis should be negative value, which means k minus 6 should be less than 0. But then there is no range of our function. But our range of our function will going to be, our k value should be the natural number. So k value should be natural number. So k value should be natural number according to the function, our question. If there is no natural number statement, that means there is no limitation of our function, which will going to be k, will going to be either infinity. So at first, let's think about the term natural number. Natural number will going to be the number that is positive. Only the positive number can be natural number. But we need to be careful that natural number doesn't include the either decimal or the fraction. It is just the integer that is positive. So if you think about the k value, that makes this whole expression equal to less than 0. But it should be the natural number. So our k value will going to be 1, 2, 3, 4, 5. So our answer for this question will going to be 1, 2, 3, 4, 5, because they said they are just trying to solve for the natural number of k. Now the most important thing is our graph of our function. So the but when it comes to solving this kind of function, we don't need x and the y-axis. So I won't really care about it, and I will just draw an approximate value of it. So there will going to be 5 cases, but then I want to draw one of their function. So our vertex will going to be in the first quadrant. So right over here, I'm just drawing an approximate value of our quadratic function, because when it comes to solving this kind of question, we don't need an exact value of our function. We can get wrong in our y or the x-intercept. Only thing that is important here is the a value. The reason why the a value is important is because when it comes to graphing the function, we need to see if it opens upward or downward. Second most important thing will going to be the location. So the second will going to be the location of a vertex. So y-intercept, x-intercept, it doesn't matter if we get it wrong. All we need is these two things. So since we knew that our leading coefficient is positive value, this will going to go upward, and it will look something like this. That keeps going upward and contains one specific point. So I can draw it better than that. We're going to look something like this that satisfies our equation and keeps going upward. And you're going to contain one specific point, which will going to be its minimum point. So this will going to be its minimum point. And if you think about its value, it can be our x value going to be 2, and our y value can be k minus 6. But then k value can be either 1, 2, 3, 4, 5, which means this function can change either right or left. What's our second way to solve for this question? First one is to convert our standard form into a vertex form that included a variable in it. Second one was just use the formula, as we have learned in a lot of videos, which was finding the x-coordinate of the vertex. In my opinion, the second one was more efficient, and we can prevent ourselves from wasting more time.